Wow, the James Webb Telescope has been fully deployed. If you're interested in astronomy or space, you've got to be excited about the James Webb Space Telescope. Here's why. For starters, it's huge. How huge? The primary mirror of the JWST is over 21 feet wide. The Hubble Space Telescope, the previous largest eye in space, has a mirror of about 7 feet 10.5 inches. By comparison, if you place the two telescopes side by side, it'd be like putting a horse next to an elephant, and elephants are enormous. There's a perfect reason why the Webb, as it's affectionately called, is massive. It has to be huge because it's not an optical telescope in the traditional sense that most telescopes are. The JWST is an infrared telescope. It sees heat. Infrared light has a longer wavelength than visible light, so it needs a larger mirror to focus that light. So what do we have here with the James Webb Space Telescope? We have two never-before things going on. We have incredible technology and incredible science missions. Both the missions and the technology are out of this world cutting edge. The Webb is a classic example of engineering in the service of science. Because of its greater light-gathering power, the James Webb Space Telescope will be able to take images of things that we were never able to see before, but have always wanted to see. Things like exoplanets, and the first galaxies in the universe, and stars and planets forming inside nebulae. And you can bet that there'll be plenty of surprises too. The James Webb Space Telescope has several technological tricks up its sleeve, which promise to provide its greatest scientific discoveries. The Webb has a coronagraph, and a very special coronagraph at that. The coronagraph is the tool that will allow the first real pictures of exoplanets. The coronagraph blocks out the bright pinpoint light of stars, which we already know have planets orbiting around them. Without the coronagraph, the starlight would make things too bright to see these planets, because planets are hundreds of thousands of times dimmer than the star. But with the coronagraph blocking the starlight, the exoplanets come into view. And the JWST coronagraph can block the light from up to 100 stars at once. We can expect a swarm of exoplanets. This brings us to the next high-tech gadget the JWST has up its sleeve, a no-slit spectrograph. Usually, an ordinary spectrograph will have a slit to allow a sliver of light to enter and be diffracted. Diffraction is the scattering of light to reveal the spectrum of the light's component wavelengths. But the James Webb Space Telescope's work is so sensitive that a sliver of light would overwhelm the optics. So a no-slit spectrograph was installed. The starlight gathered from the big mirror is sent into a fiber optic cable to send only a single spot of light into the spectroscope. And that's where the grism takes over. Sir Isaac Newton used a prism to discover the spectrum of sunlight, Roy G. Biv, as you may recall. But the Webb uses a grism. That's a compound word, like smog, which is smoke and fog. A grism is a graded prism. That means it has itsy-bitsy, teeny-tiny grooves that diffract the spot of light the big mirror sends down the fiber optic cable and into the spectrograph. The science of reading a spectrum of light is called spectroscopy. By analyzing the spectra of light from the exoplanets, the JWST will determine what gases are in the planet's atmospheres, as well as their density and even their temperature. It's an incredible advance in our knowledge. We'll be able to tell if a planet has oxygen or nitrogen, or methane, and other gases that may or may not indicate that the planet is habitable. Another Earth, perhaps. Presently, the JWST is parked in its permanent location. Unlike the Hubble Space Telescope, which orbits the Earth, the James Webb Space Telescope orbits the Sun. It orbits the Sun at one of the gravitational balance points between the Earth-Sun system. It just stays there without having to use much or any fuel to hold its position. So, as the Earth orbits the Sun, the James Webb remains parked at a spot that is also orbiting the Sun. There are 5 gravitational balance points between the Earth and Sun. They are called Lagrange points, after their discoverer, Joseph Louis Lagrange, in the 18th century. The Webb is parked at L2, the second of the 5 Lagrange points, which lies 932,000 miles out into space, way beyond the Moon. All this to observe a spot of infrared light. But first, the engineers must get, or acquire, that spot of light. To get a spot of infrared light, the 18 hexagonal mirrors had to be unfolded from their position inside the Ariane rocket that sent the Webb into space. Once the mirrors have unfolded, their positions must be adjusted to microscopic level accuracy so that all 18 mirrors produce a single image. Several tiny motors are attached to each mirror segment to make these adjustments. These motors, which must be activated individually, will gradually pull the honeycomb-like mirror segments into alignment. It's a critical part of the mission and takes months to complete. To align the mirrors to produce a single spot of light, the James Webb Space Telescope can't be jiggling around. The telescope must be kept absolutely motionless, and that requires two other cutting-edge technologies, the Sunshield and the cryocooler. In space, direct sunlight is very hot, and shadow is very cold. Therefore, the James Webb Space Telescope brought along its own high-tech Sunshield. It's huge, too, as big as a tennis court huge, comprised of 5 individual layers of Kapton film, only a millimeter thick. Each layer of the Sunshield has to be remotely deployed individually using a system of 8 motors and 139 actuators with thousands of parts. The purpose of the Sunshield is to help the JWST stay cold. The colder the better. And colder is what the cryocooler is for. Temperature can be measured 3 different ways: in degrees Fahrenheit, where water freezes at 32 degrees and boils at 212; in degrees Celsius, where water freezes at 0 degrees and boils at 100 degrees. But neither of these thermometers have a starting point. So, Lord Kelvin, in the 19th century, devised a third temperature scale, the Kelvin scale, which starts at absolute 0, the coldest temperature possible. The onboard cryocooler will cool the JWST to just 7 degrees Kelvin, 7 degrees above absolute 0. At this temperature, virtually all heat from motors is removed, and the telescope will be able to focus the light to a point without any noise, basically any motion interfering with the quality of the image. Finally, after all this incredible technology functions remotely as planned, we are almost ready to observe the infrared images from the giant multi-segmented mirror of the James Webb Space Telescope. Almost ready. A telescope can collect all the light it wants, but in the end, it must also be able to detect what it's collected. If the light is not detected, it's not truly observed. Enter the pièce de résistance, the infrared detectors. The Webb has 15 of them. The specially fabricated semiconductor material produces a slight electrical charge when struck by a photon of infrared light. The Webb's infrared detectors can produce a 1,000,000-pixel high-def image. A few of the detectors can produce a 4,000,000-pixel image. They must be durable enough to last 10 to 20 years without warping or corrupting, all while working at 7 degrees above absolute 0. In themselves, the infrared detectors on the JWST are an engineering marvel. But what are they going to take pictures of? The missions of the JWST. Well, they're cutting edge too. 70 of the first 280 target observations are exoplanets. Is there another Earth? Which exoplanets seem habitable? The Webb telescope will provide detailed spectroscopic analysis of the atmospheres of thousands of known exoplanets. For the first time, we will see images of exoplanets as they appear in infrared light. Cosmology, the study of the universe, is perhaps the primary mission for the Webb. Galaxies receding away so fast that their light is stretched into the infrared will be a prime target for observation. Hundreds of hours of observations are necessary to collect the faint infrared light from these first galaxies formed after the Big Bang. The JWST will give us a picture of what the infant universe looked like. Astronomers will learn new information about the dark energy that is driving the expansion of the universe and what role, if any, black holes play in the formation of galaxies. Star formation in the Milky Way and nearby galaxies is also part of the mission of the James Webb. By imaging hundreds of solar systems forming around newborn stars, astronomers will establish a definite history of solar system development. Now fact will replace theory, and a big step forward will be taken in our understanding of space. The James Webb Space Telescope is a bold endeavor that will mark an epoch time in scientific history.
At a distance of 640 light-years from the Sun, scientists discovered planet WASP 76b, where it rains iron. The planet is very close to its Sun and always turned to it in the same side. The term is tidally locked. The temperature on the sunny side is so high that metals melt and evaporate there. The other half of the planet is cool enough so that metals condense again and fall down as rain. Speaking of tidal locks, our moon is the same way. There's no dark side to our satellite, it's just always turned to us with one side. When the moon happens to be in between the Earth and the Sun, what we call its dark side becomes brightly lit. We just can't see it from our planet. Figures. A recent study claims that the moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. You won't believe it, but the moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Astronomers have recently found out that Mars is seismically active. Mars quakes occur there on a regular basis. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But on those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the moon's full diameter. Turns out there are plenty of planets in the universe, and even in the Milky Way galaxy, that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface there's an actual ocean of water. But it's too soon to be hyped about possible life on such planets. Liquid water is only one of many things that have to come together for life to appear on a planet. A star in the galaxy GSN 069 is likely to turn into a planet the size of Jupiter in the next trillion years. It might happen because of the star's regular encounters with a black hole. First, astronomers noticed unusual X-ray bursts that were strangely bright. They went off every 9 hours. After studying this phenomenon for some time, the scientists realized it was a star moving in a unique orbit around a black hole. The dazzling flashes? It was the material getting slurped off the star's surface by the black hole. It turned out that over millions of years, the black hole had already transformed the red giant into a white dwarf, and the process isn't going to stop whatsoever. Astronomers have found some traces of phosphine in the atmosphere of Venus. On our planet, this gas, colorless and flammable, is often found where microbes live. No wonder a new theory suggests that there might be life on Venus. But even if there was some life on the evening star, it could have only appeared in its atmosphere. Probably no living organism would be able to survive the planet's extreme environment. Venus's surface is extremely dry. There's no liquid water on the planet, and the pressure there is 90 times greater than that on Earth's surface. The temperatures often rise higher than 900 degrees. That's hot enough to melt some metals. As for vacations there, I'll pass. In fact, there's a place millions of light years away where there's a whole floating space cloud made entirely of water. There's so much of it that we could fill all our oceans 140 trillion times over, slightly more than what we need. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance thanks to which we can now thrive. But in space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water it would be enough to fill our oceans thousands of times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth not only thanks to fossilized remains of living beings, but came from outer space as well. And yet, there might just be about 6 billion Earth-like planets in the Milky Way galaxy alone. The latest data has shown that every fifth Sun-like star can have at least one planet in its habitable zone, And not just any planet, mind you. It has a rocky core and surface, and it's of comparable size to the Earth. Being inside the habitable zone of its star, such a planet would have high chances of becoming home to living creatures, microbes at least. And if there are billions of these planets in our galaxy, you could safely say that at least one of them is not only habitable, but inhabited already. And now, multiply this by the number of galaxies in the universe, also considering that many of them are much bigger than the Milky Way. This gives us billions upon billions of Sun-like stars and Earth-like planets, and some of them are surely more like ours than others. And get this, we might be able to walk upright because of supernova explosions. About 2.5 million years ago, a supernova sent cosmic rays to our planet. They triggered a series of electrical storms in the Earth's atmosphere, which turned into thunderstorms. Those in turn caused wildfires in Northeast Africa, where our earlier ancestors lived. Fires turned the forest area into a savanna, the atmospheric pressure changed, and our ancestors had to stand on two legs to survive. The biggest explosion since the Big Bang was registered in 2019. This happened in the Ophiuchus cluster, which unites thousands of galaxies. According to scientists, the blast was equal to 20 billion, that's 18 zeros, megaton explosions happening once a millisecond for 240 million years. I'll have to trust that. My math is not that good. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Marsquake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Mars quakes have been detected. Those are the first quakes on any space body other than Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses were. Maybe after midnight they're going to let it all hang out, or something. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, Earth's. It also has more than 20 layers, all of them freezing cold and extremely condensed. Remember the asteroid that wiped out the dinosaurs on Earth? Hey, I wasn't around then, but who could forget? There might have been another space show that ended badly for at least 75% of all life on our planet in the past. Roughly 360 million years ago, a supernova explosion occurred about 65 light-years away from us, and the cosmic rays sent by it swept away the ozone layer of our pretty blue ball. Wow, tough neighborhood. To see one of the most significant astronomical events of all time, we go to South America. In the Atacama Desert, Chile, we find the most advanced technology for space observation. Here, the Royal Astronomical Community members watched for 6 months as a black hole simply absorbed a massive star. By the way, these are the same scientists who proved that in the center of our Milky Way galaxy is a supermassive black hole, and even took a photo of it. For the first time in history, this incredible event happened very close to Earth. Well, the distance of 215 million light-years is considered quite close in astronomy terms anyway. Light from this event reached our planet in September of 2019, and even the most experienced scientists dropped their jaws in surprise. Imagine a star the size of our Sun, about 860,000 miles wide. Such stars have enough weight to create a strong gravitational field, holding many planets in their orbit. And now, let's place a giant black hole next to it. The hole is absolutely black, shaped like a disk, and weighs 1 billion times more than this star. The force of its gravitational field is incredible. Nothing can leave its gravity force. Objects that can move at the speed of light will still fall into this black abyss. Even light itself cannot escape its boundaries. As soon as a star enters the gravitational field of a black hole, it has no chance. At first, it tries to resist the pull of the black hole. Still, the star's outer layers begin to stretch toward the black hole, just like spaghetti. This is due to a powerful force of attraction. If you had the opportunity to extend your hand toward the black hole, you would see your fingers begin to stretch and elongate. This is because the force of attraction increases with every inch. Therefore, it acts stronger on your fingers than on your arm. That's why this process of pulling objects into a black hole is called spaghettification. The first thing to be sucked into the black hole is the star's crown. This is the outer shell of the star, which consists of hot plasma. You may notice how the star begins to shrink in size. This is because that plasma makes up most of the visible sun. When this hot plasma spaghetti reaches the black hole, it may appear to remain on the disk's edge and continue to orbit the black hole. But in fact, there is no turning back anymore. The star's particles have already hit the event horizon of the dark abyss. The gravitational field of a black hole bends light around its edges, so the event horizon looks a bit like a croissant for the observer. Boy, lots of food metaphors here. I'm getting hungry. You may also notice a kind of chaos in this ring, as if some light particles are moving in one direction and others in another. This happens because of a mirror effect. But you can be sure that whatever reaches the event horizon will, sooner or later, be pulled into the singularity, or the black pearl of the black hole. Another illusion you spot is the star particles in the event horizon moving slower. The truth is that supermassive objects like a black hole curve space-time around them, and the more massive the object, the slower time flows near it. If you hang one watch beside a black hole and another on a wall in your bedroom, you will see that the second hand in the first watch barely moves, while a whole day passes on Earth. As observers, it seems to us that the particles of light have slowed their movement, but in fact, they may have already been absorbed by the black hole ages ago. Now, massive streams of red-hot plasma splash into space, just like spaghetti sauce. When a black hole has absorbed star material, it emits powerful rays of energy at a rate of about 6,200 miles per second. This release of energy is accompanied by an intense flash. It's thanks to this flash that scientists can even detect this process in the first place. This phenomenon can be observed when a supernova explodes. When nothing remains of the star's body, we can still see stardust and other particles in the black hole's event horizon. Kinda like the Parmesan cheese sprinkled on the spaghetti. Hey, stop me if I'm taking this too far. When the process of spaghettification is completed, about half of the star's weight has been thrown into outer space as dust and glowing particles. The other half was entirely absorbed by the black hole. The scientists observed this process for almost 6 months. But what would be more interesting is to dive into a black hole yourself. Well, we can't do that yet, but we can simulate this process. Here's a little drone, our metal friend, kinda like a meatball. No, I haven't had lunch yet. Right now, it's at a safe distance from the black hole, the length of about 3 widths of the event horizon. Objects at this distance can orbit the black hole safely. A little closer, and it'll be swallowed up by a dark infinity. So, our destroyed star could have safely existed at this distance. Moreover, planets can live at this distance. And if there is a suitable source of light and heat somewhere nearby, life can exist on these planets too. But our goal is the singularity, and we guide the the drone, closer to the event horizon. After a few minutes, the force of attraction begins to strengthen, and the drone starts to stretch like spaghetti. When it begins spinning around the black disk, it means it has reached the event horizon and has started its descent into the black abyss. Now let's look at everything from the drone's perspective. All the light from the stars that it sees becomes blue. This is called gravitational blue shift. As it falls into the black hole, its gravitational field pulls the photons of light down, giving them energy. Their wavelengths grow shorter, so the red photons change into blue. The drone continues to fall and is already completely hidden from our eyes. And all that the robot sees is a bright, thin blue beam. Now it's in complete darkness. There's absolutely nothing here, not even time. Here, time goes so slowly that our entire solar system could grow old and cease to exist during a minute spent in a black hole. But our drone will live until its battery is empty. Hey, the drone sees a small bundle of light again. and it's getting closer and more prominent. Now the drone will experience the same fall, only in reverse. Once the drone leaves the singularity, the heart of the black hole, it will be on the event horizon once again. The light from the stars gradually changes from blue to red. Then the drone is thrown into outer space, perhaps in some faraway galaxy. Well, returning from a black hole is just a theory. Some people think that black holes are a kind of wormhole that can lead us to distant places in space. But so far, these theories are considered fiction. Black holes are quite challenging to detect. The problem is they are, well, black, just like space. They don't emit light like stars, so they can only be detected by gravity anomalies. Despite this, scientists believe there are a vast numbers of black holes in our universe. They're born when a massive star collapses under its own weight, and given the infinite number of stars in the universe, black holes are probably a common phenomenon. Scientists believe black holes have their own lifetimes. This is because of Hawking radiation. A black hole loses mass, and so, to continue existing, it has to absorb massive objects, like the star we just watched. But if the black hole lives in deep space, it has less to absorb and will most likely begin to shrink until it just disappears. Like this plate of spaghetti.
More than 1 million Earths can fit in our Sun. New research shows that between 20% to 35% of suns eat their own planets, and a quarter of planetary systems orbiting stars like the Sun had a chaotic past. The very thing that gives life can also take it away. All the planets in our solar system revolve around the Sun, and they all do it in a somewhat consistent way. It's most likely that they stayed that way ever since they first came into the picture, but not all of them. This chaotic existence means that a solar system had a lot of planets in the litter until the host sun decided to melt them away. Our solar system is panned out perfectly so that no planet's gravity interferes with each other. The gravitational force on Jupiter is a lot tougher than Earth's, which means that if Earth gets close to Jupiter, we'd be another moon for Jupiter. The planet is so big that if Earth were the size of a grape, Jupiter would be the size of a basketball compared to it. Even with the best technology in the world, it's difficult to tell if stars do, in fact, eat their planets. The best way to study this is to observe binary systems. That's just a sciencey way of saying a system with two stars orbiting each other. Usually, the two stars were formed around the same time from the same gases and the same conditions. It means they should contain the same elements, more or less. When you open your eyes in the morning, the sunlight that's been traveling for millions of miles greets you. The closer we get to it, the hotter it is. But the rays traveling from the sun also contain certain chemicals that make it unique. The chemicals that are associated with the sun are light materials like oxygen, carbon, hydrogen, and helium. You can find some other stuff in it too, but these are the main ones. By studying these elements, you can learn the history of a solar system with enough detail to determine if it was chaotic or smooth. Scientists studied 107 binary systems composed of suns like ours by analyzing the light. Since each system contains two suns, they compared and contrasted them to see the differences. They observed the stars with a thin outer layer, having different elements than their companion. All suns contain light elements, but there are some that have rocky elements, like iron, silicon, and titanium near the sun. These elements are associated with rough terrains that you'd find on the surface, but they're out there floating in the middle of space. The thinnest outer layer is especially rich in iron compared to the other layers. Many stars are twins at birth. Even most of the Milky Way stars have a buddy in a binary system. It means our sun is pretty unique for not having a partner. But there are some theories out there that suggest that the sun may have lost its twin in the past. It's around 184 light-years away and is called HD 186302. This might be our lucky star. A stellar nursery is where thousands of stars are born. They're made up of gas and dust that gradually collapse under their own weight. Our sun may have started in such a way 4.6 billion years ago. And when they're mature enough, they go out into the open, usually with their travel buddy. Actually, scientists claim that up to 85% of all stars could be in binary pairs or have more buddies, but over 50% are dual pairs. The only problem is that we can't really see it, since it strayed from its original orbit an eternity ago. But traces of it can be found in the Oort cloud. That's the vast cluster of space consisting of comets, space rocks, and ice in the outer edges of our sun's reach. They float around quite a lot, since they're far off the sun's gravity and can easily be knocked out of their orbit into open space. Flying through such a space is no different than flying through any random void of space. The reason why some of these light elements in space contain rock elements you'd find on the surface of a planet is because the sun knocked them off their orbit and devoured them as they got closer. It also happens when a star becomes too big in its place and starts eating everything around it. According to scientists, if a star eats a planet, it can make it go chaotic and spin so quickly that it eventually rips apart. But don't worry, there's a very low chance of the sun devouring the planet in the near future. Stars are formed when a huge cloud of hydrogen and helium grows until it collapses under its own weight. The pressure increases and reaches extreme heat levels we can't even measure. Eventually, the hydrogen atoms lose their electrons, causing the hydrogen to fuse together and release energy, countering the gravity collapsing. But when the gravitational force overpowers the hydrogen fusion, the star begins to expand and becomes a red giant. And then, after around 1 billion years, the hydrogen in the outer core will go away, leaving plenty of helium hanging around, which will fuse with the rest of the elements around. And once all the helium disappears, gravity will shrink the red giant into a white dwarf. And when it's completely gone, the remains of the star release tons of gas and dust into space. Scientists claim that our sun has between 7 to 8 billion years left before it reaches that stage. But even if that becomes a reality, it wouldn't happen overnight. Something like this takes millions of years to take place. But what if the sun decided to devour us overnight as we speak? The planet would start feeling hot in seconds. Every slight degree change can lead to some catastrophic events. Ice caps can melt in a matter of seconds and flood the coastal lands. Even little islands in remote areas of the world will be submerged. And as it gets hotter, every snow-capped area will melt instantly and turn into desert-like climates. Some places will burn, and your everyday objects will melt on the spot. The Earth's interior will also get hotter, allowing volcanic eruptions to happen across the world. Antarctica will melt from the heat, as well as the volcanoes erupting inside. And just in a matter of minutes, the whole planet will turn into fire and ash before it explodes into tiny bits floating in space, reaching areas we've never even heard of. But no worries, something like this won't really happen. In case the sun knocks us off our rotation, the results would be different. It'll also get hot because the magnetic field around us protects us from the sun's radiation. And once we get knocked out of place, the magnetic field gets tarnished, and the extreme heat from the sun will boil us. The gravitational force will be unstable, so the physics of our everyday life will be chaotic. We'll have to wait 5 billion years from now when the sun turns into a red giant. It'll grow in size, eventually eating up Mercury and Venus. Chances are, Earth will also be on the menu. If Earth were to move only 900,000 miles closer to the sun, then it would be uninhabitable. It may seem like a lot, but it's only 4 times the distance between the Moon and Earth. Detecting the chemical composition of the sun rays in solar systems that are further away could help scientists find other Earth-like planets. Since the atmosphere around these planet-eating stars changes the chemical composition, we can detect which solar systems out there have had a calm past. The main thing we have to observe is if the planets have a healthy orbit cycle. With nothing else getting in the way, we can assume that the planet could follow the same steps as Earth did for humans to be here. But this process will take ages, since there are millions of nearby stars similar to our sun. The odds of finding a planet similar to ours are near impossible at this rate. But if so, then there might be life on those planets. There will be no way of knowing if it's intelligent life, but they might have had the same evolutionary fate as us. Brightside channel is happy to announce the first video of a recently discovered secret star map of great antiquity and significance. We're presenting to you archaeoastronomy. Cleverly hidden in the southern hemisphere stars, this map predates any of the early star maps published by the Dutch or English explorers of the 16th and 17th centuries. Just imagine, this map served as a navigational guide for the early 16th century Spanish Empire's naval expeditions below the equator. It also provided the geographic locations of natural resources in the New World. If anything was top secret back then, this star map indeed rated that designation. When above Earth's equator, sailing vessels used the North Star as their directional guide. Located almost directly above the North Pole, the North Star, Polaris by name, remains the only motionless star in the sky as the Earth spins during the night. Time delay photographs centered on the North Star show star trails of the circumpolar stars, while the North Star remains virtually in the same spot. Above the equator, Polaris is a sure signpost to the north. The height or altitude you see Polaris above water tells you your latitude above the equator. But below the equator of Earth, the North Star is not visible. Below the equator, there is no South Pole star. As the expedition of vessels under the flag of Spain approached the equator, the North Star continued to drop lower and lower behind the stern of the ships. It became evident to the Spanish and Portuguese sailors on board that Polaris would soon descend below the waves and no longer be visible to guide them. The sailors became anxious, sailing into unknown waters without a directional guide. That's when they created the first constellation of the secret star map of the southern hemisphere, Crux, the Southern Cross. A bright constellation appearing in front of the bow of their ships gave the sailors confidence that they had a navigational guide for their journey south. Crux is portrayed on the flags of several sub-equatorial countries of the southern hemisphere: New Zealand, Australia, Samoa, and Papua New Guinea, all in the South Pacific, as well as Brazil in the South Atlantic. These vastly different geographical locations are essential for unraveling discrepancies between the modern constellations and the secret star map, as we shall soon see. The second constellation created by the sailors on their secret star map was at least as necessary as Crux, but far smaller and dimmer, tiny in fact. Made of just a few dim stars, the Musca constellation, the Fly, was a welcome discovery to the sailors, at least as welcome as seeing the Southern Cross. The southern celestial hemisphere contains many more stars than the northern celestial hemisphere. The southern sky is literally packed with stars. It's because our sun is somewhat above the middle of the disk of the Milky Way. When people on Earth above the equator look up, we look out of the Milky Way. People in the southern hemisphere are looking down into the disk of the galaxy and see many more stars, nebulae, planetary nebulae, and the Milky Way's companion galaxies, the large and small Magellanic Clouds. It's why Southern Hemisphere astronomy contains many of the newest, biggest, and most powerful telescopes and observatories. There's so much more to see from down under. Why then, among the vast multitude of stars in the southern sky, is the dim little constellation Musca so important? Why would the sailors place this on their secret star map, right below the Southern Cross? Because, on a ship, if a fly bites you, it's good news. A fly can only mean one thing: the land is near. And after sailing from Spain, the land was a very welcome sight. The next constellation placed on the secret star map is off to the ship's port side. Heading south, the port side, or left side, would be to the east, toward the archipelago of islands off the coast of Brazil. The third constellation is another dim minor constellation, the Chameleon. The Chameleon served as a secret code for expeditions to follow. It means, don't go there. Well, okay, go there if you want chameleons for dinner, but not much else. No natural resources. The constellation of the Chameleon is a no-go sign. Don't be fooled by these islands. They're mostly barren. Bare to the starboard. That's where the mainland is. Another no-go sign further east of Chameleon is Bolans, the flying fish. Not anything for the dinner table either. Maintain your heading southwest. Now, as we head down the coast, we can begin to overlay the secret star map onto the map of South America. When we do that, we immediately encounter an anomaly, the constellation Apis, the bird of paradise. Apis doesn't jive with South America. Birds of paradise are indigenous to the islands of the South Pacific, not South America. We're going to see as we continue our journey around South America, following the star map developed by the Spanish and Portuguese sailors, that many birds are depicted in various locations. Therefore, the constellation Apis is properly located on the mainland of South America as a conspicuously beautiful bird, but not a bird of paradise. Maybe the sailors saw a banded cotinga, or perhaps a Stresemont's bristlefront, or any of several kinds of brightly colored parrots, or perhaps, even more likely, the white-tipped quetzal, which lives in Venezuela and Guyana. In any case, Apis denotes a bird with a forest habitat, a valuable natural resource for the Spanish Empire to exploit. Sailing between the Chameleon and Apis, Spanish ships hugged the coast of the great landmass of South America. Passing the mouth of the then unnamed Amazon River, the sailors marked the location with the constellation Hydrus, the water snake, a clear icon of what the Amazon had to offer. Cape Branco, or Cabo Branco in Portuguese, marks the easternmost point of land on the South American continent. There's a tastier dish in the sky and sea off its shores, dourado, the swordfish, a pricey item still on the menus of upscale Portuguese restaurants. A valuable marine resource, dourado sure beats chameleons and flying fish for dinner, and the ship's rations of salt pork. The toucan is the next bird on our star map as the ship cruises down the coast on what is now called the Brazilian Ocean Current. The presence of tucana in this location, comparable to Argentina, indicates the natural resource of nuts and fruits. Next up is the constellation of the Phoenix. The phoenix is an immortal bird of classic mythology. It rises from all-consuming flames and is reborn. Our sailors at this point have sailed further south than any European had ever gone. Their destination was the Spice Islands near India, and they were way off course. The landscape on shore had become frightening. Tierra del Fuego, the land of fire with active volcanoes spewing molten lava. Overhead, never-before-seen aurorae lit up the night sky with undulating curtains of red, green, and blue. The current had turned against them and become cold. The ship struggled to navigate the Strait of Magellan, the doorway to the Pacific. The constellation of the Phoenix represents their successful entry into the Pacific and long-awaited turn northward. They were liberated from the land of fire and felt reborn as they finally were able to turn north. And this is where all published star maps since 1603 place Grus, the constellation of the crane. But Grus is not a crane. Cranes don't live in South America. It's time we clear up the mystery of the mixed-up constellations. Apis isn't a bird of paradise. Grus isn't a crane. And we're going to see that Pavo isn't a peacock. All of the mixed-up constellations are a product of a star chart published by the Dutch cartographer, that's mapmaker, Petrus Plancius, 1552 to 1622. Based on celestial observations made by one Peter Kaiser on the island of Madagascar. Madagascar was discovered by a Portuguese expedition of 13 ships in 1500 and visited often by Portuguese sailing vessels in subsequent centuries. It appears that Peter Kaiser may well have known a Portuguese sailor who communicated to him the constellations of the southern hemisphere that were developed by the Spanish and Portuguese sailors aboard the Spanish expeditions around South America, our secret star map. Although there is no evidence to support that claim, it explains the mix-up in the identity of the constellations. They are really South American birds, as in our secret star chart, and not birds of the East Indies, like on all official modern star charts. Grus isn't a crane, it's a flamingo. Flamingos live in Chile. The sailors going up the west coast of South America saw flamingos. This very same constellation that is called Grus today had been called Phoenicopterus in the early 17th century. Phoenicopterus is Latin for flamingo. Grus is a flamingo. A similar misnomer occurs with the constellation Pavo, the peacock on modern star charts. Pavo is Latin for peacock. Peacocks don't live in South America either. Yes, peacocks are indigenous to the South Pacific. However, the word pavo in Spanish means turkey. And yes, turkeys do live in Spain. But And here's the kicker. Turkey in the Portuguese language is Peru. A conspicuous bird of the country of Peru is the condor, the largest flying bird in the world. The constellation of Pavo is a condor, which is much more like a turkey than a peacock. The presence of condors means there's game meat ashore. We're now at the equator again, having sailed up the west coast of South America, and there is the constellation Indus, the river to India. The southern equatorial current heads across the Pacific at that location. And there's your secret sailor's star map in its entirety. Oh, be sure to stock up on limes in Lima, Peru. It's a long trek across the Pacific. Limeys, as sailors are often called, must get their vitamin C to stay healthy.
It was the year 2017 when astronomers spotted a bright star hurtling out of the Milky Way. It was moving incredibly fast at a speed of 2 million miles per hour. That's almost 4 times as fast as the Sun orbits around the center of our home Milky Way galaxy. It takes our star more than 225 million years to complete one journey. Anyway, back to our star, the Wanderer. The main issue with it was that it was moving against the direction in which most stars travel around the center of our galaxy. Even more bizarre, it consisted of totally different star stuff. Astronomers managed to identify its composition. The star was made up of heavy metallic atoms. At the same time, most of the other stars consist of way lighter elements. The wandering star got the name LP 40-365. It was moving so fast that it literally dashed out of our galaxy. This made scientists believe that the space traveler was pushed out of its place by some kind of cosmic disaster, like a supernova. A supernova is the largest explosion that can take place in space, an explosion of a star. It happens after irreversible changes start in the core of a star. Supernovas can occur in 2 ways, in binary star systems and when there's a single star. Binary stars are 2 stars orbiting around the same center. At some moment, one of the stars, a very dense white dwarf, starts stealing matter from its companion. After some time, this thief accumulates too much matter, which causes it to explode into a supernova. Or it can be a single star nearing the end of its life. It's running out of its fuel. More and more mass is flowing into the core of the star. In the end, the core becomes so heavy that it fails to withstand its own gravity. After the core collapses, a tremendous amount of energy is released in a supernova. But astronomers still can't figure out how a supernova could send LP 40-365 flying. There are more questions than answers. Was it a companion star that got flung out by a shockwave created by a supernova? Or was it a piece of the exploded star? A new study based on the collected data has shown that the star, which is a white dwarf, keeps slowly rotating around its axis. Astronomers are almost sure it means LP 40-365 is indeed just a chunk of space debris, and not a full-fledged star. This wandering piece somehow managed to survive one of the fiercest space events. But after making such a conclusion, scientists realize something amazing. LP 40-365's unusual features could appear after the star witnessed a supernova. Even though this event happened lightning fast, the entire makeup of the star got changed. Most stars consist mainly of helium and hydrogen, but LP 40-365 is different. It contains such heavy elements as magnesium, oxygen, and neon. It must have been the supernova that added these atoms to the star's composition. By the way, astronomers consider all elements that are heavier than helium to be metals. This means that after witnessing the supernova, LP 40-365 became metallic. Right now, the star doesn't have its own planets, but NASA's Transiting Exoplanet Survey satellite, which is on the lookout for distant planets passing in front of their host stars and dimming them, has noticed a curious thing. LP 40-365 brightens and then dims again every 8.9 hours. It might mean that the star pulsates, but usually stellar pulsations are much less regular. A more plausible explanation is that the star's surface is uneven, and as it spins, sunspots are brought into and out of view. And it's great news, because after astronomers figure out how fast the star rotates, they can understand what happened to it around 5 million years ago during the supernova. Bright blue exoplanet HD 189733b looks peaceful and eerily familiar. Doesn't it resemble Earth? But this appearance conceals the planet's terrifying nature. There, the winds blow at 5,400 miles per hour. It's 7 times the speed of sound. But that's not the worst. It rains glass, sideways, in this scorching hot world. Neutron stars are ultra-dense collapsed cores of giant stars. They emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. The most plausible theory is that this signal was probably produced by a disk of dust surrounding the star. But there isn't enough evidence to confirm this idea. Mercury is the fastest planet in the solar system. It zips around the sun at a breakneck speed of more than 100,000 miles per hour. That's around 40,000 miles per hour faster than our home planet. It's one of the reasons why a year on Mercury equals 88 days on Earth. Mercury is the planet that orbits the closest to the Sun. That's why if you were standing on its surface at its closest approach to our star, the Sun would look more than 3 times as large as it does on Earth. The Black Widow pulsar is a rotating neutron star that is munching on its partner, which is a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. There's a stellar nursery in the constellation Centaurus, and even though this place is called a nursery, it's anything but peaceful or safe. It's made up of hydrogen and newborn stars and is located in a nebula around 6,500 light-years away from Earth. A nebula is a giant cloud of gas and dust floating in space. The intense energy baby stars emit makes hydrogen clouds glow ominous red. This energy is so powerful, it's eating away dark clouds of dust. Astronomers can see them disappear like lumps of butter on a hot frying pan. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice, and this ice is burning. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means the exoplanet travels very close to its parent star. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X. And this ice remains solid despite such incredibly high temperatures. Jupiter is the largest planet in the solar system. It's 318 times as massive as Earth. It's also 2.5 times as massive as all other planets of the solar system combined. But here's a paradox. If this gas giant got even more massive, it actually becomes smaller. The added mass would make the planet denser, and this would cause it to start pulling in on itself. Astronomers claim that Jupiter can eventually end up being 4 times as massive as it is now. But at the same time, its size won't change. DGSAT-1 galaxy is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thin. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that DGSAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Saturn's moon, Hyperion, is one of the most bizarre-looking moons in the solar system. But the appearance isn't the strangest thing about this space body. The pumice stone-like rock is pockmarked with countless craters, and it's also charged with static electricity, which is flowing out into space. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. It means that at least some part of the planet is diamond. Ceres is the most massive space body in the asteroid belt between Jupiter and Mars. It totals almost a third of the entire mass of the whole belt. But at the same time, Ceres is the tiniest of the dwarf planets out there. It's also the only dwarf planet that dwells in the asteroid belt, and also the only one that is located in the inner solar system. Astronomers sometimes call Jupiter a failed star. The gas giant indeed contains a lot of helium and hydrogen. But its mass isn't enough to start a fusion reaction in its core. And that's exactly how stars produce energy. They fuse the atoms of hydrogen together under extreme pressure and heat and create helium. In the process, they also release light and heat. Jupiter could start a nuclear reaction and become a star only if it was 70 times its current mass. Space is completely, eerily silent. That's because in the vacuum of space, there's no atmosphere, and the sound waves need some medium to travel through. That's why worlds with atmospheres like Earth are full of noise. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have enough mass of 1,000 sedans. One theory claims that tons of micro-black holes could be created right after the Big Bang. Some scientists even go so far as to say that a couple of mini black holes pass through our planet every day. Every hour, the sun sends more energy to Earth than our planet uses in a year. Even though people are now using much more solar energy than a decade ago, it's still a mere 0.7% of the world's annual electricity usage. There might be moons orbiting other moons, but astronomers haven't agreed on this theory yet. Planets orbit stars, moons orbit planets. But why can't there be moons, also known as submoons, moonettes, and moons? Researchers claim that moons could exist, but the host moon has to be massive enough and the moon small enough. There must also be a large distance between these moons and the host planet. Jupiter is the most massive planet in the solar system. This means its gravity is also the most intense. It's 2.5 times as great as what we have on our home planet. Once, the gas giant's gravity even tore apart a large comet called Comet Shoemaker-Levy 9. Then the planet eagerly swallowed the chunks of the former comet. If you were standing at the equator on Mars, the temperature at your feet would feel like that of a warm spring day, but your head would be literally freezing. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars, but one of them, floating 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates never-ending flashing auroras in the planet's atmosphere. Europa is one of Jupiter's largest moons, even though it's smaller than Earth's moon. But the cool thing about this satellite of the gas giant is that it's covered with ice. And some of this ice is smooth, which means you could skate there. And a 3-foot axle jump you can perform on our planet would take you 22 feet into the air. At the same time, the landing speed on Europa would be the same as it is on Earth. Haumea, a dwarf planet orbiting the Kuiper Belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning large object in the solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile wide ring circling it. Astronomers haven't managed to figure out how or why it appeared around the dwarf planet. 11 Earths could fit across the equator of Jupiter, and if our planet was the size of a grape, the gas giant would be as large as a basketball. 9 spacecraft have already visited Jupiter. 7 of them just flew by, and 2 orbited the huge planet. The most recent of them, Juno, arrived at Jupiter in 2016. The craters of the moon's south pole are likely to be the frostiest place in the whole solar system. The crater's floors are always in the shadow. That's why the temperature never rises above 397 degrees Fahrenheit, even during the day. If you decided to fly a plane to Pluto, your journey would take around 800 years. You'll find the highest mountain in the solar system on an asteroid called Vesta. Its peak rises 14 miles above the base of the mountain. This makes Rise Sylvia, that's what the mountain is called, almost 3 times taller than Everest. Saturn's rings weren't discovered all at once. It happened gradually. That's why they were named alphabetically in the order scientists found them. Now they go like this: D, C, B, A, F, G, and E. A day on Venus is around 243 Earth days long, but the bad news is that you'd have to wait for a weekend for 3 years. All because a day on Venus is longer than its year. A solar phenomenon called terminator events is taking place at the Sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen almost every decade. The winds on Neptune are the fastest in our solar system. Most of them can reach the speed of 1,600 miles per hour. Almost any of these enormous storms could easily swallow our entire planet. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because a ring of dust and debris circling it makes it look like a giant eye staring into your soul. The intimidating star is more than twice the mass of our Sun and is 25 light-years away from Earth, which isn't that far away considering distances in space. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, the planet's gravitational forces will tear Phobos apart. It'll probably result in the formation of a ring around Mars. An asteroid the size of a car enters the atmosphere of our planet every year. Such an intruder could wipe out a small town off the face of the Earth. Dust and smoke would rise into the atmosphere, preventing sunlight from reaching the surface of the planet. It would cause the temperatures all over the world to drop and the climate would change. Luckily, such asteroids burn in the atmosphere before they even come close to the surface. The radio signal produced by a spacecraft when it contacts Earth is less powerful than a light bulb in your fridge. By the time this signal reaches our planet, its power is only 1/billionth of a watt. No wonder that antennas gathering these super weak signals are huge. The Deep Space Network that detects signals from spacecraft has dish antennas that measure up to 230 feet across. That's more than the width of a soccer field. In 1999, NASA lost a Mars orbiter because one engineering team was using the metric system, and another was doing calculations with the help of the imperial system. Nebulas are giant clouds of gas and dust. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger. And their gravity gets more powerful. One day, a nebula's mass becomes so great that it collapses under its own gravity and forms a new star. Around 4,000 light-years away, in the constellation of Scorpion, there is the Butterfly Nebula. Its wingspan is greater than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an insane 450,000 degrees Fahrenheit. This means it was formed from another huge star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass, or a butterfly. If you decided to lump together all the known asteroids in the solar system, their total mass wouldn't exceed even 10% of the mass of our moon. A cloud of water vapor is floating in space. It surrounds a supermassive black hole 12 billion light-years away from Earth. The cloud contains 140 trillion times the entire volume of water on our planet. Astronomers think this water cloud appeared just 1.6 billion years later than the universe itself. The densest objects in space are neutron stars. They are the size of a small city, yet their mass is about 1.4 times the mass of our Sun. A single teaspoon of neutron star material would weigh 1 billion tons. and a neutron star's gravity is 2 billion times stronger than the gravity of our planet. In 1993, the Galileo probe was traveling past a miniature asteroid. It was no more than 20 miles across, and still, the tiny thing had a 1-mile wide moon. Astronomers have discovered tons of moons orbiting minor planets in the solar system since then. We live inside the Sun. The star's atmosphere stretches way beyond its visible surface, and our planet is well within its reach. That's how the gust of the solar wind creates such a breathtaking phenomenon as the northern and southern lights.
Hop on board. Hurry, we don't have much time. We're on a cosmic journey to find the biggest star in the universe. The first star we pass is our own Sun. By far, not the biggest one out there, but it's still massive. You could fit 1 million Earths inside it. That means if you think of the Sun like a basketball, Earth would be half the size of a pencil eraser. If we put all the planets on one side of a scale and the Sun on the other, the planets wouldn't stand a chance. The Sun makes up 99.9% of all the mass in the entire solar system. Mass is basically how much stuff or matter something is made from, and it's what you can thank for stars shining. You see, the more matter in a star, the thicker and hotter its core becomes. This starts a chain of chemical reactions. Hydrogen atoms get smashed into each other to form helium, releasing an incredible amount of energy. That's the star's light and heat. So, bigger stars also equal brighter ones. But with all those reactions going on, this shortens a star's lifespan. When it starts to run out of fuel, the star will enter the giant phase. It'll expand and turn red. Which brings us back to the task at hand. The biggest star we'll find is likely to be on the edge of its life. Switching on our hyper light engines, we soon arrive at the Lumen 16 system. Here, we'll find one of the smallest stars out there, a brown dwarf. Small here means about the size of Jupiter, but they're small for stars. Brown dwarfs are also called failed stars because they don't have enough mass for those chemical reactions. That means they're not as bright, but they're super dense. All the matter in them is packed together so tightly, they weigh 80 times more than Jupiter, even being the same size. And if you think that's something, just look at a white dwarf, even more tightly packed. This one here is Sirius B. It's also about the size of Jupiter, but it'd weigh as much as the Sun. It emits a dim white light. Once it runs out of gas, it'll turn red and cool down. Now let's fly closer to its giant neighbor, Sirius A. You easily see this star from Earth. No telescope needed. Twice heavier and more than 1.5 times wider than our Sun. It's the brightest star in our night sky. Now we fly 550 light-years away from Earth to the constellation Cassiopeia. Almost 100 years ago, a cosmic explosion happened here. It expanded the atmosphere of the star Gamma Cassiopeia, and some gases were thrown into space. After that, it became the brightest star in the constellation. It's 10 times wider than our Sun. On to the famous North Star. Funny enough, different stars have had this title over the years, and more will take it in the future. That's because Earth's pole star changes every 26,000 years. Imagine our planet like a spinning top. The northern pole will shift around in a little circle, pointing at different stars to the true north. The current one is a supergiant 37 times wider and 5 times heavier than our Sun. It's easy to find in the night sky. It's on the very tip of the Little Dipper's handle. Get ready now. We're setting off for the eye of the storm, the center of our Milky Way galaxy. To see the next star, we need to switch to infrared mode. This pistol star is hiding from us in space dust. In just 20 seconds, it emits as much light as our home star does in an entire year. And its size is jaw-dropping. It's 420 times wider than the Sun. But it's still not the most luminous star known to humanity. That would be a blue supergiant in the constellation Triangulum. Meet B416. It's almost 10 million times brighter than the Sun. But the brighter a star, the faster it burns up all its fuel, and the shorter its life. Compared with a red dwarf that barely glows and burns fuel much more slowly, its life will be hundreds of thousands of times shorter. 3,400 light-years from Earth, there's one of the rarest celestial bodies in the universe. It's a yellow hypergiant called Rho Cassiopeia. Among the countless stars in our galaxy, there are only a couple dozen of these. And even though this star is extremely far away from our planet, you can still see it in the sky without needing a telescope. That's because it's 300,000 times brighter than our Sun. It also helps that the thing is 900 times wider than our home star, too. And its color tells us that its fuel reserves will last for a long time. When Rho Cassiopeia starts to turn red and expand, it'll be one of the biggest stars in the entire universe. Now, we move to the constellation Orion. The star is in our sights. Betelgeuse, one of the largest ones visible to the unaided eye. 700 times the size of our Sun. If it took our star's place, its surface would touch the asteroid belt. That's between the orbits of Jupiter and Mars. It would engulf the 4 inner planets, Earth included. But this star has astronomers very excited. They predict Betelgeuse will explode in a fantastic celestial show in the next 10,000 years. It'll be the greatest astronomical event of all time because we'll be able to observe a supernova at a close but safe enough distance. The exploding star will shine as bright as a half moon. It'll be visible in the daytime sky for a year and at night for several more. Now we venture to stars that exceed the Sun's width 1,000 times. Mu Cephei is a hypergiant boasting the title of the reddest known star. Its color tells us that the fuel gauge is getting closer and closer to empty, but it's still so big that it could hold 1 billion suns in it. And because of its mass, this star will eventually become a supernova or even a black hole. Let's take a trip of almost 4,000 light-years from home. Here it is, a red supergiant called Vy Canis Majoris. It's one of the biggest and brightest stars of the Milky Way. It could fit 3 billion suns. And even though it's so huge, this thing is surprisingly light, only 17 weights of the Sun. In the context of celestial bodies, you could call this star an inflated balloon. In the next 100,000 years, Vy Canis Majoris will explode in a hypernova. Gamma radiation will destroy all life in the local part of the universe. But this star is so far from our solar system that it wouldn't mean any harm to us. If we placed My Cephei in the center of our solar system, it would bulge all the way out to Saturn's orbit. To remind you just how far away Saturn is, think of it this way. It takes the Sun's light 8 minutes to reach Earth. To get to Saturn, it takes well over an hour. Compared to this massive star, the Sun is just a grain of sand. It's one of the most luminous and reddest stars in our universe. The bigger and redder the star, the closer it is to its end. So, we're not looking at just a titan of the universe, but also one of the oldest celestial bodies out there. The second biggest star in the universe is UY Scuti. It's about 1.5 billion miles wide, 16 times the distance from the Earth to the Sun. This is a pulsating variable star. Its brightness changes about every 2 years. UY Scuti is a record breaker in fuel combustion per year. Scientists expect it to evolve back to hotter temperatures like a yellow giant. Our journey is coming to an end. Before us, we behold Stephenson 218. It takes 20,000 years for light from this star to reach Earth. It's hard not to see this red supergiant on our tiny terrestrial home. It's 2,150 times wider than our Sun. We'd need 10 billion suns to fill its volume. For comparison, the average beach contains only about 5 billion grains of sand.